Okay guys, we're gonna continue. Now we have this question 10, where it's saying a tournament organizer conducts a survey amongst 150 members at the local sport clubs to find out whether they play tennis or not. So this is the table of a survey where we have a male and a female. We have this row here, or this column, where you have 50 and 50 of a male that play tennis, and 20 of a female that play tennis. Not playing tennis, we have 30 of those males and female of those don't play tennis. So in order to complete this table, let's find the total, because we're going to need the total of both male and female and playing tennis and not playing tennis. So if we can add this one here, we're gonna get 80. If we're gonna add this one here, we're gonna get 70. Total of the two, it's 150. If we're gonna add the 2 here also, we're gonna get 80. We're gonna add this 2 here, we're gonna get what? 70. So now let's go to the question. Now they're telling us what is the probability that a member selected randomly is a female. So we're looking for a probability of a member being a female. So now this is the female. They didn't specify that it's playing tennis or not playing tennis, so we're just looking for a female. Member of a female, how many of them? There are 70 of them, all over the total of 150. Since we are looking for what? A probability. So simplifying this, 70 over 150, it's what? 7 over 15. Hope you understand that one. And then now B, saying now a female now, and they play what? And they play tennis. A female and it plays tennis. So now probability of a female and it plays tennis. And it plays what? Tennis. Now let's go to a female now. Female and it plays what? Tennis. So what do we have there? We have 20 all over the total of everything. It's what? It's 150. So if we simplify this one, it's 20 over 150. We get what? It's 2 over 1/5. I hope you understand that one. Thank you so much. Then let's go to the other one, which is 10.1.2. now it's saying, is playing a tennis independent of a gender? Now they are not specifying which gender, is either a male or a female. They're just saying a gender, and they say motivate your answer. So by necessary calculation. So in order for you to tackle this question, it's either you're gonna use a male or a female. It's up to you. How do you motivate your answer? Since in our previous question they asked us about the female, I will just do the female part. Then after that you can also do the male part, just to check your answer. I will not do that one. I give that to you to do that one in order finding what the male part. So we need to know first thing that probability of A in terms of the independent, in terms of probability of B is equals to probability of A and B. I hope you understand that one in terms of independent. We need to prove that they are not like this. We need to prove that they are like this. So now we do have the probability of a female. We have already found one, which is probability of a female, which is 7 over 15. And then we need to find the probability of playing tennis, because it also includes tennis. So play tennis, probability of playing tennis. Now this is tennis. It's not specific of male or female, it just need a probability of playing what? Tennis. So it's gonna be 70 all over our total, which is 150, which is 70 over 150, which gave us what? 7 over 15. Just the tennis. And then now we need to find a probability, or we do have a probability of a female and a player in it plays tennis. We do have this one. That's what? It's 2 over 5, 2 over 15. Now to prove this thing, we must first times the 2. Then you can see that timesing this 2 is gonna be equal to this. If it does be equals to this one, then it's the event is what? Is independent. Now let's do that. Probability of a female times the probability of what? Of playing a tennis. It's what? 7 over 15 times 7 over 15, and our answer here 7 over 5, 7 times 7 over 15, which gives us 49 over 225. Then from this, it's telling us that this is not equals to this, so therefore the event is not what? Independent of what? Of a gender. Now remember, you must go and do the male part where they play tennis, and see that it's not independent. It has to not to be independent because they didn't specify which gender. Okay guys, going to this question now, question 4. It's saying the table below represents the favorite sport for 120 learners. So we have a sport here where we're comparing between boys and girls, and then those sports we have golf, tennis, and squash. On the boys that play golf we have 32, on girls that play golf we have 12, and then boys on the tennis we have 18, and girls on the tennis we have 23. Then boys on the squash is 20, and then girls on the squash it's 15. And then we also have the total of the golf, and then also have the total of each and every sport, and the boys and the girls. Now let's start tackling these questions. Now they are telling us that determine the probability if a learner is selected randomly as a learner who's selected, and his boy who plays tennis. A boy who plays tennis, very important word here, or a squash. Now let's go here to do we have this boy. Now this boy, now they are telling us this boy is either playing a squash or a tennis. Now probability of being a boy, and then you play a tennis or a squash. Now it's either a tennis or a squash, so we don't know which one. Then we need to add these two. It's 18 plus 20 all over the total of everything, which is 120. What do we get from that one? 18 plus 20, which is 120, which is 19 over 60. Is a probability of a boy playing tennis or a squash. This was 4.1.1. This is now 4.1.2. We are looking for a probability of a learner who plays what? A tennis. A learner who just plays tennis. a learner who plays tennis. Not specifically which learner, it's just a learner that plays what? That plays tennis. Going to our table now, a learner, tennis, this is the tennis. This is the learners who are playing tennis. The total of those learners is what? It's 41, because we don't know which specific learner, all over the total, which is 120. See, you can simplify this one. Just like this, we can simplify it further. Now let's go to 4.1.3. now they are telling us a learner who is a girl. Now we're looking for a probability of a learner who is a girl. We don't know what that girl is doing, is either playing whatever sport. We just know the probability of that one just being what? A girl. So it's a girl. Going to a girls now. How many girls do we have? We have 50 girls. So we have 50 girls out of what? Out of 120. You can simplify that. 50 divided by 120, it's 5/12. Hope you can understand that one. Then go to 4.2 now. They're saying, are the events of choosing golf as a favorite sport? Now we have a golf as a favorite sport and being a boy are independent. Now golf and being a boy. Hope you still remember that this important, or this big word here, independent, where we find it by the probability of A and the probability of B being equal to probability of A times the probability of what? Of B. Because we're going to use we are proving that it's going to be like this, because this is what they are telling us to prove. Now we have to find the probability of a golf. Going to our table, probability of a golf. Now a golf, we don't know which is a boy or a girl, just need the probability of a golf. The total people who are playing golf are what? Are 44 over the total, which is 120. Now we're gonna have to find also the probability of what? Of a boy. Going to our table, this is a boy. We are not specifying which sport is a boy playing, just need a probability of being a boy. So being a boy is just 70, which is the total of all the boys all over 120. Now what we need to find also, now we need to find the probability of a golf now and what? A boy. How do you find that one? Now we are going to a golf, we are going to a boy. If this is a boy, this is a golf, both of them they meet here, which where we have 32 all over. What is the total of everything? It's 120. Now we need to times these two and see with these two, is it going to be equals to this, according to what the independent is saying here. If they are equal, then your event is going to be independent. Now let's find the probability of a golf times now the probability of a boy. Probability of a golf is 44 over 120 times the probability of a boy, which is 70 over 120. If you can times these two, it's 44 over 120 times 70 over 120. What do we have? We have 77 over 360. Now I hope you can see that this one is not equals to this one. Now therefore our event is not what? Independent. I hope you see that one, that our event is not independent. Since they say therefore the probability of a golf and boy is not equals to the probability of a golf times the probability of what? Of a boy. I hope you understand that one. I hope you do. Okay guys, this is our last question, which is another question 12, which is saying a group of 554 people with a green or blue eyes were randomly selected in order to determine whether or not green or blue eyes are dependent on the gender. The results that are tabulated below. So we have the green and the blue eyes when we have a male and a female, and then we have the total of the green eyes and the blue eyes and the total of being a male and a female. So now going to our first question, which is 12.1.1. If a person is randomly selected, determine the probability that it will be a female with what? With green eyes. Now we are looking for a probability of being a female with what? A green eyes. Looking for a probability of being a female and with what? With green eyes. Now let's go to a female. This is a female and this is what? This is green eyes. I hope you see all of them, they are meeting here in 147. Then the probability we divide by the total, which is 540. Let's see, we can simplify this. 147 divided by 540, it's giving us 49 over 108. I hope you understand that one. And then going to this 12.1.2. Now, after analyzing the results, a grade 12 learner concludes that the probability of having green eyes is independent of a gender. Now, this is very important before you start answering a question. Is he correct? Substitute your answer with the relative calculation. Give all the answers into decimal places. Also follow these instructions because it's very important that you follow these instructions. Now, coming back to this one of green eyes is independent of a gender. Now here it's gonna be up to you which gender are you going to use. Are you going to use a male gender or are you going to use a female gender in order for you to determine or to prove that these green eyes are independent of any particular gender? So for me, I'm gonna use a female, which I started already using a female here. So I'm gonna give you a homework that you're gonna do the part of what? Of being a male. Now we already find independent. I hope you still remember that probability of A and B is equals to the probability of A times the probability of what? Of B. I'm gonna apply this. Now we have already find the probability of a female with jasmine also and what? And green eyes. We've already find this one. Now what I'm going to do now, I'm just going to say the probability of female, probability now of just being a female. I hope you see the total of being a female here is just 240. Probability of being a female, then we divide it by its total, which is 540. And then now looking for a probability of what? Of just green eyes. Probability of just having green eyes. Probability of just having green eyes. The total of having green eyes is what? It's 330 all over our total, which is 540. 0. Now proving this, now we need to times these two. Then the probability of a female times the probability of the green eyes. We have 240 all over 540 times 330 all over 540. This is what we have. We need to times the 240 over 540 times 330 over 540. But we needed to round off our answer into two decimal places, so we have 0.27. And then now here, where we have a probability of being a female and also having a green eyes. We already find this one. We know it's 49 over 180, but we need to just round off it. What is 49 over 180? If we round off this one, we see here we find 0.27. So this is very important. Since these two, they are equal, since the probability of being a female and having a green eyes is equals to a probability of just being a female times the probability of just having what? Green eyes. This is equal. It's telling us that therefore our event now is independent and the learner is correct. I hope you understand this one. I hope you do. Thank you so much.